Hello friends, welcome back to C Field Academy. So today we are going to discuss an important data structure which is array. So this video is part of the series of videos we are doing for data structures and algorithms, where we discuss each of the data structures that we have in greater detail along with different operations and examples as well as the algorithms. So let's get started with today's topic, which is in fact the most simplest one of the simplest of the data structures, which is array. So we'll discuss the following topics as part of today's video. So we will start with a basic introduction to what an array is, why is it important, and how it looks like and things like that. Then we will move on to see various operations that are possible on this array data structure. Then we will see a little bit on how an array is actually implemented in various programming languages. We won't go into programming languages, but as such, because array is a simplest data structure, it's more or less implemented in a very similar way across languages. So we will just see a little bit on how an array is actually implemented, how it is accessed, and then we will move on to each of these operations that are possible on array in detail. We'll see each of the operations with an example and an algorithm as well. So we'll start with the assign operation, which is the most simplest one. Then we will move ahead with the insert and the remove operations. Then we will see the search operation, how a search operation is performed on an array. So finally, after the operations, we will see the complexity analysis of each of these operations. So a little bit based on how how these operations perform, so that we can compare it with other data structures later on. In fact, here I would also recommend you to see one of my other videos where we discuss the data structures and complexity analysis in a bit detail, which gives a very good idea of how basically we perform an analysis, complexity analysis on various data structures. I'll make sure to link that video up here so that you can look at it. Then finally, before ending, we will see the different variants of an array which are possible, which are generally discussed in computer science. Then at the end we will see a short exercise for you guys to try it out based on the items we cover in the video. So friends, let's get started with array. So the first question automatically arises is, what is an array? So array is a data structure which means it's a collection of elements, and it has a special property. In fact, the simplest property is that the elements in the data structure are stored at contiguous locations in the memory, which means they are stored one after the other, and together all these data elements would represent a sequence, and that's what we call an array. So basically, if you have been across any of the primitive data structures, which is an integer or a character, so they usually occupy one space in memory, not necessarily one byte, but one space. So when we arrange those primitive data structures one after the other, and then we form a collection, that we call it as an array. In fact, each element is directly accessible. So each element of the array is directly accessible using an index and the base location of an array. We'll see it later how this is possible. So the simplest form of an array is just a one-dimensional array, which means it's just a single dimension. In fact, multiple dimensional forms are also possible. Let's say a matrix, which is a two-dimensional array, and three-dimensional arrays, and similarly n-dimensional arrays, and they have different applications, or they have applications in computer science in variety of fields. Now some of the applications of array include representation of vectors. If you have been in physics, matrices in math, let's say we want to add matrices, multiply matrices, we can easily represent it using a one-dimensional or a two-dimensional array. In software engineering, it can be used to represent database records, and also many of the complex data structures which we will see later on, like heap, hash table, stacks, all these can be implemented using this using the simplest data structure, which is array. So it is a very important data structure, I would say, in terms of computer science, and lot of the other complex data structures depend on array or use array as its underlying implementation. So here is an example of an array. You can see now this array has 9 elements, which starts from 2 and ends at 0. So these elements 2, 3, 4, 1, 9, 7, 5, 3, 0 are stored one after the other, and the entire collection of elements is actually called as an array. So let's now go ahead and see what are the different operations that are possible in an array. Excuse me. So as always, if you have followed the other videos, or if you have seen my basic data structure video, you would notice that one of the important property of a data structure is what are the operations and how these operations are performed on a data structure. So in array, basically there are 4 main operations that are possible or available. First and the most important one is actually the assignment operation. Now what it does is it just assigns an element to a position in the array, thereby replacing the existing element at its position. So here is an example. So let's say I have this array and I want to I have an array which has 6 elements. In fact, it has some numbers, it may not have any numbers, and there is a value 4 which we want to assign to the third position. So what we would do is we would just replace the existing element, which means 8 will be replaced by the element 4. So it's just a mere assignment, which means just that position or that value is replaced with the desired value. So this is a basic operation of an array. Next is an insert operation. Now the insert operation assumes that we have a flexibility of increasing or decreasing the size of an array. Otherwise it really doesn't make sense, because if the array size is fixed, as we have in certain implementations, let's say in C, C++ or Java, then the insert operation may not make sense, because we cannot expand or increase the size of an array. What we can do is just do an assignment operation. So insert assumes that we are adding an element to a position. It may be start, middle, or any specified position in an array. So let's see how the insert operation looks like. So we have a same array with 6 elements, and let's say we want to insert an item 5 in 4th location, which means it will be inserted just after 4. So what we need to do is we need to first increase the size of an array, which means we increase the size of an array by 1 and then push the elements to the right. 197 will be pushed to the right, and then we will make space and then insert 5 in between 4 and 1. So that's the basic idea of insertion. Similarly, removal is exact opposite of the insert operation. Now here what happens is we remove the element, and then we also reduce or remove the space that gets created. So let's say we have the same array 2, 3, 4, 197, and we want to remove an element 1. So what we need to do is we need to capture or remove the extra space by moving the elements, shifting the elements to the left, and also thereby decreasing the size of an array, in this case from 6 to 5. Alright, cool. We will see each of these operations in detail a little later. So let's not be bothered about how it works, why it works, and things like that. Awesome. So the last one, which is the search operation. In fact, search operation means we are searching, we are given an element and we want to search if that element is present in the array. So in normal sense, what we do is we just go through the array one by one and then see if it's found. If it is found, we return the position where the element was found, and then we are done with the search operation. Cool. Now let's see how array is generally implemented. Now here we just restrict ourselves to one-dimensional array implementation, but multiple dimensional array can also be implemented in a similar way. It's just that we just need to extend the notation a little bit. So basically an array, how it is defined is we have a base location, which means the location where the array starts, the first memory location. And then we have a size variable. That's all we need to define an array. We need a memory location and then the size, how many elements the array contains. And then we can define, or we can access any element of the array. We know the boundaries, we know the starting location. Now this is an example. We take the same array which we had. Now here we have a variable size as 6, and then what we have is, let's say we have an array which is named as ARR. So ARR would also mean the base location of the array. So which means which is what we are going to say. The base location is generally indicated by the array name. So in this case, ARR defines the base location of the array. And then we have a size, which we already discussed. That's the size of the array. And we also, to individually access the elements of an array, we use a subscript notation, which means a value or a number inside square brackets. Now that indicates the index of the element we want to access. So let's say we have ARR3, which means we want to access the third element, that is 1, 2, 3, which is 4. So ARR3 essentially means go to the third element starting from array, or starting from the start. So that's how actually we represent an array, and that's how we access an element in an array. And in most of the programming languages, actually this is how an array is generally defined and used. Now in case of one-dimensional array, the subscript notation is just extended to having 2 square brackets which denotes the x and y position of the element we want to access. But anyway, we currently consider that as out of scope because it's a little more complex. So I'll try to make another video on multidimensional arrays, because I think matrices, multidimensional arrays are really an important concept when we want to solve complex problems like matrices, Queen's problem, or the distance vectors and things like that, or some graph algorithms like finding shortest path and things like that. So we'll cover that in a separate video. Alright, awesome. So let's now go ahead and see each of these operations in a little detail. So first one is the simplest operation, which is assignment operation. So here we assume that we are given an array, we are given a number, and we are given a position in the array where we want to assign the element to. So what we generally do is we just check if the position is valid, which means it's non-negative and it is less than size, because if it's greater than size, then we cannot allocate or we cannot assign it. If it is not, and if it's an invalid position, then we just return, which means we do not perform the assignment operation. Otherwise, we just place the element to the position using the subscript notation, and then we will return. So it's as simple as that. So here is the algorithm for the assignment operation. So as you can see, we are given an array, which is the base position. We are given a position where we want to assign an item and the item which we want to assign. Now we are assuming that the array has an internal variable called size, which captures the range or the number of elements that are currently, number of spaces that are currently allocated in the array. So what we essentially do is we just see if the position that is being entered is less than size, so which means it's a valid position. Then we just assign the item to array position, which means assign item to the index position in the array, and then we are done. And if the position was, you know, if the position is invalid, which means if it's greater than size, then we just print invalid position. In fact, we could also add here that, you know, position is greater than equal to 0, which I have missed it, but you know, we are assuming the position cannot be negative, so we could add another condition as we discuss. Let's say position here should also be greater than equal to 0. It should be non-negative, but it's kind of an extra checking we are doing. But anyway, it gave a general idea of the algorithm, or general steps for the assign operations. So here is how a pictorial representation of the same. So let's say we have this 6 element array, size is 6, and we are calling the assign operation with 3, which means at third position, and we want to assign an element 4. So what we do is we just go ahead and first check the position, which is 3 is less than the size here is 6. I haven't written it down, but that's obvious. And since it is less than 6, we will just go to step 2 and then assign array position is item, which means 4 will now be assigned, 4 will replace 8, and as a result we will have the again 6 element array, which looks like this. Alright, cool. So let's now go ahead to the next operation, which is the insert operation. Now, to insert an element at a position into an array, we are assuming we are given a position, positive position, and we want to insert an element at that position. So as usual, as we did in the assign operation, we'll check if the position that is given is valid or not. So what is a valid range? So valid range means it should range between 1 to size, or in fact size plus 1 in this case, because we are allowed to, you know, increase the size of array. And that's why we need to check if the position is between 1 and size plus 1. Otherwise, which means if the position is greater than size plus 1, or if it's negative, we just return, we do not do an insertion. Otherwise, we are assuming here, by the way, that we can increase the size of an array. Now the insert and remove operations assumes that. Now in certain implementations in programming languages, we are not allowed to increase the size of an array, so there the insert and remove operations do not make sense. But you know, since we are discussing this as a general data structures and algorithms, so we will just assume that we are allowed to increase the size of an array. Now since we are inserting a new element, we need to increase the size of an array by 1. So that's the next step which we do. We increase the size of an array by 1, and then we need to make space for the element, which means all the elements from position to the end of the array needs to be moved 1 space to the right, and then only we can make space. So once we move the elements, we just do the assignment operation to the space that we made for the element, and then we are done. So let's see this how it looks like pictorially. So let's say we have the same array which we had 6 elements, so size is 6, and we want to insert an element 5. So what we do is we move all the elements. Now we want to insert element 5 at 4th location. So what we need to do is all the elements after 4th location, which is 1, 9 and 7, needs to be moved right, so that we can make a space here for 5, and then only assign the value of 5. So what we do first step is increase the size of the array as 7, and we'll move the elements 1, 9, 7 to make space, additional space for the new element which we want to insert, and then we'll just insert the element 5. Cool. Now let's see this the insert operation as an algorithm. So this is our insert algorithm. We are given an array, we are given a position where we want to insert, and then we are given the item which we want to insert. So this will insert an item at the position if possible. So what is the first step? Now this also assumes that we have an internal size variable which stores the size of an array. So the first step is to check if the position is valid or not. So first we will check if position is less than size plus 1. We are assuming position is also greater than 0. Then only we will do the increase the size of the array. Otherwise it doesn't make sense if the position is given a very high number, and we will just return back. So what we do if it's a valid position, the first step which we do, which we already discussed, is to increase the size of an array, size equal to size plus 1. Then the next step, or the next few steps, is to actually move the elements from the position to the end, one step to the right. So that's what we do. So we start from I equals to size to position plus 1, which means we go to the end of the array, and then step by step what we do is we move the element, that is array I equals to array I minus 1, which means we move the element one by one to the right, finally till we make space for the element, which is after step 4. So then what we do is in step 5 we assign the element to the position, because position is now vacant, and then once we have assigned, we are now done. So that's how the algorithm looks like. Otherwise, if the position was invalid, we will just print an invalid position and then we will return. So let's say we have this array over here, we call the insert operation with array 4. 4 is the position which we want to insert, and 5 is the element which we want to insert. So in this case position is 4 and item is 5. So the first step in this case, as you can see, there are 6 elements, which means size is 6. So first step is to check if position is valid. Position is 4, definitely less than 6 plus 1, which is 7. So we will go inside the if condition, which means we will go ahead and then we will increment the size. So size now becomes 7 in the step 2. So size becomes 7, which means we have basically allocated an extra space over here. And then what we do is we start with a loop in step 3 and 4, I equals to size to position plus 1. So we have I is equal to 7, and then what we do is in the array we will move element. Okay, I think here there is a mistake. It should be array I minus 1. The subscript should be inside it. So this I minus 1 is inside the square bracket. So what we do is we first move the element from one element less, which means 7 now is moved to the position to the right. Similarly, we will then decrement I will now be size minus 1, and then we will move 9 to the position where 7 is. Then we will move finally when I is position plus 1, which is 5, we'll also move 1 to 9. So once we do that, it will look something like this, and that will make an extra space at the position for 5. And once we have that, then in step 5 we just assign 5, and then we are done. So that's how the algorithm for insert is. I hope it was pretty easy to understand. If not, you could just rewind the video and then look at it again. Awesome. So let's now move ahead and then see the next operation, which is the remove operation. So remove operation is pretty opposite to what insert was, because here we just need to delete an element and then eat up the extra space that's created. So again, the first step is to check the validity of the given position. So if position is greater than size or negative, then we just return. Otherwise, what we do is we move all elements starting from the element after the given position to the end of the array one position to the left. So which means starting from the element which we want to delete, we will overwrite it by the next element, and then we will keep doing it till the end of the array. So at the end what will happen is the size of the array will also get decreased because we have deleted one element of the array. So let's take the same example of 6 elements that we had. Now here the array size is 6, it's not 5. And then let's say we want to delete an element 1. So as we delete an element 1, the first step what we do is we'll move 9 to actually replace 1, that is to left side, and then we'll move 7 to 9. And when we do that, there will be an extra space here that is created, and then that we will delete it by reducing the size variable. So we can see here the size now becomes 5, it's not 4, it's a typo over here. So as we delete the one element, 9 and 7 takes its place, and then extra space is now reduced. Awesome. Let's see the algorithm for this. So the remove operation takes an array and just the position in this case, because we just want to delete the element that is present at the position. So as always, the first step is to check if position is valid, so which means we'll check if position is less than size. If it is too huge, then it doesn't make sense to delete it because we don't have that many spaces in the array. So what we do is essentially is we start from position, which means the element that we want to delete, to the end of the array, to one element less than the size of the array, and then we move element towards the left. Now here also I made this mistake here. The I plus 1 should be in the square bracket, so which means we basically replace array I with the next element, which means array I plus 1, and we keep doing it till we reach the last but one element. And then what we do is we decrease the size of an array. It shouldn't be size plus 1, but it's size minus 1, and then we are done. Let's see this example in action. Now let's say we have this array size is 6 over here, and we want to delete an element which is at 4th location. So 4th location means it's actually 1 that we want to delete. So what we will do is we will start with, I'll fix this again, sorry for that. So we'll start with I, so I is position, and we will replace I with I plus 1, which means 9 will go and replace 1, and then we will move I again, and then 7 will go and replace 9, and then we are done till we go to the second last position, because the last element will anyway have to be deleted. So as you can see, what has happened here is 1 has been replaced by 9 and 9 is replaced by 7, and the extra space at the end got deleted when we executed the step 4 where size equals to size minus 1. Cool. So as a result, the size of an array got reduced by 1. Awesome. So that was the remove operation. Now let's see the next operation, which is the search operation, which is in fact a simple operation. So to search for an element in the array, what do? Is we start from the first element in the array, which means we loop through each array element one by one using an index and compare it with the given element. So in search we are usually given an element, so we start from the first element, we loop through the array, and then we compare and see if the value is same as the given element. If yes, then we return the value of the index, which means we say that the element was found at so and so position in the array. If not, we return a value -1 or some invalid value indicating the element was not found in an array. So the algorithm looks very simple. In fact, we just loop through, start from I equals to 1 to size, and we check if array I equals to key. Now key is the element we are given which we want to search. Now if we find it, then we just return the index of the array, which means saying the element was found at location I. If not, which means if we have exhausted the entire array by searching and we didn't find anything, at the end in step 3 we just return -1. Now let's see this example in the array which we had. So we have an array of 6 elements and we call search array 9, which means we want to search for the element 9. So we start with I equals to 1 over here and I points to 2. We will first compare with 2 and 9. 2 and 9 are not same and hence we'll move ahead. We then compare 3 with 9, not found, so we continue till we reach with I equals to 5. Now there we will see that we find 9, which is what we are searching for. So once we compare, we will get a match, 9 equals to 9, and hence what we'll do is we'll return the value of I, which means we'll return 5 as a result of the search operation. Awesome, that was pretty easy, isn't it? Cool. Now let's go ahead to the next step, which means we'll just see how each of these operations perform in terms of complexity or time complexity, in fact. So let's start with the first operation, which is an assign operation. Now assign operation is pretty easy. What we just do is we just have one operation wherein we replace the element which is present at the position by the new item, and then we are done. And hence the total operation is just one, or we say it's just an order one. Assignment is order one. In fact, it's the cheapest and the fastest, I would say. Next we see the insert operation. Now this is again applicable only if the data structure or the language allows inserting and deleting of elements in an array. Now in insert operation, what we do is, other statements aside, there is one for loop which starts from I equals to size to position -1, which means I starts from the end of the array over here and then till the item that we want to insert, let's say somewhere here. What we do is we keep moving the elements one by one like this. So in fact there is one loop, and then if you see this, the number of operations that it performs is size minus position, which is approximately order n in the worst case if let's say we were to insert the item at the first location, which means if we want to insert the item at the first location, we have to move the entire array in the worst case, that's why we say the insert operation, or the total number of operations maximum possible, is order n. Cool. Now similarly the remove operation, similar to the insert operation. Now here what we just do is we start from the position to the end of the array and we keep moving elements to the left, and this is what we perform to size position to size -1, which means size minus position times, which is essentially again order n in worst case. Let's say if we were to delete the first element, then we have to move the entire element one space to the left, or we have to traverse the entire array once, and hence the remove operation is order n. Okay, the last, which is the search operation. So search operations is basically a simple loop which starts from the first element and then goes until the last element. So if you notice, this also is order n in worst case. So let's say the element is not found, then we search through the entire array once, which is order n. Of course this is faster if the element is, let's say, found earlier, but we are saying in average or in the worst case it's still order n. Awesome. So let's this is a mistake over here. There are too many bugs here, there are too many typos that I have made, but I hope they are not that huge. So here is a list of all the operations and the time complexity that we discussed. The assignment is order 1, which is probably the fastest and the cheapest. All the three other operations are order n because they will involve going through the array at least once. Cool. So that was complexity analysis. Now let's discuss a little bit about the various variants of the array that are normally discussed in the context of computer science. Now the first one, which we already discussed, is the multi-dimensional array, which means a two-dimensional array, which we call normally as a matrix, and similarly an n-dimensional array, it can, I mean, the number of dimensions can be as much as possible. So essentially an n-dimensional array is a one-dimensional array of n minus one dimensional array. So this is the first variant, and this is very useful. In fact, if you are to, you know, if you are working in computer science, you will definitely end up using multi-dimensional arrays in any of the programming languages or in anywhere in computer organization, operating systems, programming, software engineering. This is a very important and data structure which we normally use. The next is a dynamic array. Now a dynamic array is an array wherein the size of basically array can be increased or decreased at will and at different points. Now this is an important kind of array. In fact, when we dealt with the insert and delete operation, that's what we assumed, or we at least assumed that the array size can be increased by 1 or decreased by 1 very easily. But in dynamic arrays, we can actually sometimes double the size of an array, sometimes delete a bunch of array, or insert blank spaces in between the array. So that's why the name is dynamic, and these type of arrays also have its usage in computer science. They are pretty useful at times. The next is an associative array, or basically a map or a dictionary, sometimes called as a hash map. Now in this case, the array indices may not be numbers. The array indices itself could be a string, or they may not be sequential. In fact, in different programming languages we have associative arrays. Sometimes they are called by different names as well, but in a way they are arrays. In Python we have basically a dictionary. In Java we have hash maps. So yeah, so that's where this kind of array comes in. Alright, so looks like we are at the end of this video. I hope you enjoyed it till now. If not, definitely post your comments or anything that you want me to improve upon, and I'll definitely attend to those. So before we end, here is an exercise based on the today's video. So today's video was about arrays, so that's why the question. So let's assume we have an empty array initially, and we want to empty array of size 4, and let's insert 4 elements, 5, 10, 12, 8. So draw a diagram, or code it in a language and see how it looks like. What happens when we assign 4 elements to a given array of size 4. Then insert at position, which means insert an element 7 at third position in the array. Draw a diagram, move the elements if necessary, or if we are coding it in a language, make sure to move the elements and increase the size of the array. Next is search for an element 10 in the array if it's present or not. Next is insert 9 at the end of the array. Now remember, inserting at end of the array is pretty easy. We don't have to move any elements. So you will realize if you add the element 9 to the end of the array. Next, go ahead and remove the element at second position in the array, and make sure to swap or move the elements again to reduce the size of an array. Then search for the element 10 in the array again and see if it's present or not. So yeah, that's all guys for today. I hope you enjoyed the video. Make sure you like, subscribe, share, and also press the bell icon on the channel. And I hope you really enjoyed the video, and make sure to give some comments or suggestions on which things that I can improve upon, or if there are any certain things that you want me to cover in data structures in greater detail.